So I say again, next week we have a break because I will go to the Nangang for the trade show with the Intel and with 佳士达跟 Intel 邀请我们实验室去展览。我们是跟就是那个医学院的外科部做那个肺结节嘛，还有做复健的那么下礼拜要去那边展览因为我们做的蛮好的，就3个礼拜把 Intel 的东西 OpenVINO 把它弄整合起来，他们很高兴，提供我们很多，就我们是白老鼠的，提供很多东西。所以下礼拜 we'll take a break next week. Don't come here, okay? And so previously talked about PCA, right? PCA LDA, and so PCA and the LDA, and then we talk about supportive vector machine. Okay, LDA is a linear discrimination. Supportive vector machine is a non-linear discrimination because they have a kernel function. Okay, so for the GA, I talk back to here. We talk about deep learning. So last week we talked about the PCA. So it's a PCA, original one, right? And we try to train the eigenvectors. Then PCA copy the eigenvector to here. So this encoder, this is BMA, this projection weight. So the PCA, this eigenvector is actually W is coefficients for the network. So we back to here, continue here. Okay. So for the GAN, if you use the PCA, this encoder, this eigenvector, those parameters W are the eigenvectors. So many eigenvectors. You copy the eigenvector to the decoder. So from original, you project to based on several eigenvectors. You have a projection weight. So this low dimension, this high dimension, you become low dimension, probably only 10 chord, 只有10个码. Based on this is low dimension projection code, you can reconstruct back to the original one. That's a PCA. Okay, but you will lose the information because for the PCA, the encoder, the eigenvector for the encoder and the decoder are the same eigenvectors. It's not good. So GAN, they complete all the training. So their analysis, the eigenvector for the analysis and the eigenvector for the decoder synthesis, both are different. So after you project to the eigenspace, the co-projection weight and reconstruct, the reconstruction result will be the same as or closer to the input because this is your loss function. This is no loss function. This just use a singular value decomposition to factorize. So this without without learning. Okay, and this is learning. So loss function, so that the output will close to the input. So there's a GAN, use this one. So back to the GAN. So GAN, we have an analysis. We have a synthesis of generator. Okay. And GAN also has a good thing that because PCA, both are the same. So their PCA, so their separation is not so good. PCA only what? PCA only consider the between relationship. PCA is considered between. They don't consider the within. So PCA has this problems. They will sometimes they will mix together， 还是会分得不好。So that's why we need discriminator for PCA. When we do face recognition, you can use PCA plus LDA or use SVM because LDA and the SVM are discriminator. PCA is not discriminator. So if you only use PCA, okay, actually it's not so. Compared with this LDA is, sorry, compared with the GN, this is better. Okay, so back to here. So we have a GN, we have an analysis, we have synthesis. Basically, this is PCA. But GN, this part is better than this one. The third part, we need discriminator. So that's why we need, for the GAN, we need 3 steps. First one, second one, the same as PCA, but the GAN is better than PCA for the first 2 parts. For the third part, this third part, in the PCA we have LDA, right? And we also have an SVM for discriminator. But LDA is a linear discrimination. SVM is non-linear discrimination because they have a margin. They have a kernel function. Kernel function is an activation function. So for the deep learning, the discriminator is closer to the SVM because they have an activation function. 这样知道哈，就是你最后做分类还是要 discriminator 嘛。那 discriminator 的话，你用什么？用 LDA 或用 SVM， 就是你用 linear 的或是 non-linear 的。那一般的 non-linear 一定比较好。但 non-linear 就我刚刚讲 non-linear 2个比较好，一个就是以 SVM 来讲，一个就是用 margin， 一个是 activation function。那在 GAN 里面，基本上就是 activation function。然后会讲这些，就在那个 tutorial 那边会讲 activation function 的东西。所以 non-linear 绝对比 linear 还好，就这样。OK， 所以 GAN 需要这个 discriminator， 所以在这里我们就不用 LDA 那个方式。但是我们讲到物理意义 physical meaning 这2个方法的 physical meaning， 就我刚刚讲 physical meaning 是 what the advantage of LDA is what is they consider between and within. Okay, in supportive vector machine, they don't have a between, they don't have a within. So they use margin. They use margin instead of within and between. SVM, they use margin instead of between and within. But they also have the kernel function. So that's the SVM. So overall, what's the best method for face recognition? So for face recognition, the best paper they consider within, they consider between, they consider kernel function. 最好的，目前看到最好的 face recognition 的 paper， 它刚讲kernel 这样，它的 margin， 它考虑到 within 的关系，它考虑到 between 的关系，它考虑到那个 margin 的关系，最后它因为它有 activation function， 它4个都考虑到。所以目前最好的 classification 的方法是考虑到这4个因素。因为我是那个 face recognition 专家，我还是有看，所以这样 paper 后面有点复杂。但是你如果看到就是当你在读，有时候读 face recognition 的话，那个 paper 你可以回来看我这边刚刚那些讲义，他用 cosine theta， 他用 projection 这些观点，为什么？因为它有一面好像比较的时候就讲维度，可分类的时候又提高维度，至少它都是4个观念来做这样子。那这个又跟 GAN 有关，所以我帮你怎么整理这样子。那我们继续上次的讲义的东西。那上次实际上提到是 那这边提完了，今天提完了，上次提到这个。Okay, so last time we talked about this one, supervised, unsupervised, semi-supervised. And right now, semi-supervised is good to use. It's very good method. Okay. And reinforced learning, I talk about this self-learning, self-supervised. It's getting hard. So we talk about reinforced learning just for a little bit. So what's a reinforced learning? Basically, it's like this one, this example. What's this one? Is a suppose this you have a state. State mean what? The image. You take a photo, you take an image. So it's a state. State is what? Is a 这种状况，一张影像，就你看得到 observation 看得到的。And then after we call policy or actor, it's meaning you train a parameters pi, this parameter pi, and then what's your action? 你要做下一步是什么 ？So for example, this you have a black this chest here and white chest here. You take this photo, input to this network, and this network will output because next one suppose is black. 黑色要下起 they will output action, they will output a position. So we'll put this black one to here because the action is the position of this one in this image. So next one output will be here. So 你就把黑棋放这边，这 action. So input is the image, output is the position of this black chess. 那这样的话，因为下一个是做什么？下一个很重要是 and then so that this will be environment. So you invited the important thing for reinforced learning is we call the reward. 就是你要给他 reward. 那什么叫 reward? In this one, suppose I'm black, I have a black chess. 我是黑棋的。那 you need to wait until the final of the game over. So if I win, suppose I win to 100, 就是100 loop, 就是下100个 chess, 下100个 chess. 我下100个，你下100个，最后结束了。If I win, and I will label for each step, one step, label all be 1. 1 is meaning I win. If I fail, I will label to be 0 or -1. 0 is 0， 就是如果我这盘棋输了，就 label 0，就每个步骤都0这样子，叫 reward. So reward had 2 kind of reward. One is that you need to wait until what's the trajectory? 有很重要的 trajectory 是步骤，就是第一个 SDM state take one photo, you do one action, and you have one reward. And then take a second photo, the other action, second photo, the other action, and the other reward until the end of this one. So if I win the game, all the reward will label to be 1. If I lose the game, all the reward will label to 0. That's one kind of situation. The second situation is to play the game. Play the game, the same 2 situations. But one situation is each time when you hit something, 你只要打 ，sorry， 你只要这个很不好意思，我说 robot arm 好了，用这个 robot arm， 是 robot arm。So if I pick up， 是用这个好了，抱歉，前面的也是这个。这个没有认领，错了，这个对不起，这个才是。The other label is this one. If I pick up fail and label to reward will be 0. If I pick up successfully, pick up the label will be 1. 就是你每个动作做 label 给它这样子。So label are 2 kinds. One is until the game over. The other is each time you do the labeling. So then sometimes they say game, you play the game. If you hit something, you win and you label to 1. Otherwise you label to 0. So labeling 有2种，一种是直到游戏结束后再 label， 全部再 label 一次，从后面到前面 label 一次。那一种是你当场做就当场 label 这样子，这里有2种。那这是当场 label， 成功就一直全，但是成功就是 label 0，成功就1，然后失败就0这样子。所以这是 reinforced learning 这样子。所以这个 labeling 上 reinforced learning 的话，最终是 label， 你怎么做 labeling？ 所以它整个 trajectory 最主要是 image and action。那以这个来讲的话 ，action 就是你要下哪个位置。那你如果是那个 double on 的话 ，action 就是你要去抓，就是到底要去抓，或是说你那个什么，如果是走棋盘格的话，就是你要向前、向后、向左、向右，你要向前，就是走那个老鼠走迷宫，这老鼠走迷宫。那老鼠走迷宫的话，你的 action 就是你要往前、往左、往右或往后，这个 action。但是你的 reward 是等到你整个走出来的话，都成功，那条路就会整个路径就会 reward 成1这样子，否则0。So reward is very important. So reinforced learning is take a one photon state. You do one action. Action is like the robot will continue to move, or the mouse will go forward or backward or something like that, and then reward 就这样子。Label, so label is very important. 大概讲到这边。那只是顺便提一下说 ，deep learning can do the embedded, and in my lab we use a TX2 or NX. And right now we have Intel in the NUC. They have a CPU plus OpenVINO. So we use this one instead of this one. This is NVIDIA, and this is Intel. And the price, this one is about 10,000. We want 10.2. 12,000， 12000块，那这个差不多，这2个价钱差不多，这2个价钱差不多，而且2家在竞争。好 ，and the last one is we in our lab we do the AMR， 就那个支架车跟手背，然后we have a ROS， we use ROS。ROS 1 and ROS 2. ROS 1 is you have a master. So you have master to control different kind of robot. Suppose you have AGV, 2 AGV, and then you should have a master to control both. That's not good. ROS 2 is you don't need a master. You can two machines can communicate to each other. So this is machine to machine. So this is end to end. So I find Intel has this one. Intel has a ROS 2. So we'll use this one. And what I say is that in industry, the ROS 2, many companies start to use ROS 2, but in academic, many people still use ROS 1. Because we don't have have information talk about ROS 2. So 我们跟 Intel 合作，他们就 ROS 2这样子。这大概让你知道，所以这是学生专题生做的。还是那个 AMR 东西。This is map, so they can this starting position and ending position. So this is the the path, so they can move from here to here. So they will walk, they will run. So this is okay. ANM 这种车，这是来打 the camera here. So okay, we have a camera, we have a LiDAR. So let's go to the position here, and it will start to scan and try to find the face of the patient, the face of the patient. And after they find the face, and they will turn on the speech recognition, do the communication. 他们可以沟通这样子，可以灯光做的蛮好的，就这个再走回去这样子啊。那 for the this is the other for the M to M the ROS to M to M 是 machine to machine， 那这就是车联网。所以有些东西自驾车还没发生，在那个 AGV 这边可能 AMR 就发生了，就是这样才会自动去沟通的。Okay, so this is AMR and this is AMM. This is our robot, this is our robot. And this is the this 那个半导体那个晶圆片这里，然后你会去沟通。So this is based on ROS2. 这是物流，做东西公司的物流，厂方的，这是那个全家的物流，但是另外一个是晶圆厂的，摄影这是 camera here， 那这里去照一张相，让他知道高度在哪里。显示这里有晶圆，大概是这样子，所以是那两个就自己就走，自己去攻击自己的。那这个比较笨，这个没有视觉上，但是怎么，但是 QR code 在这里是根据 QR code 来讲。那我们这样视觉进去的话，就不需要这个第三个 QR code。所以这个这个领域还有很大空间可以发展。AMR 就是还没那么聪明。OK。So this is the end of our first lecture about deep learning. Here we talk about the second one. 讲一下，那这门课我本来没有要讲这个讲义，但发现还是要讲，这比较容易懂。So this is I modified 的李宏毅老师做的很好，那改很多。前面都讲过了，我就跳过去。他英文写错，把它改。写错了。这前面我们都讲过了，就跳过去。好。Okay, so when you design a deep learning, how do you design a model for the deep learning? So 3 steps. First step is we call topology or network. It's meaning how many layers you want to have, and each layer, how many neuron you want to have. Okay, so this first one is we call topology. Without training, just topology 是空壳子，就你那个 weight for W and B has no value， 没有值，只是你的架构把它设计出来这样子。所以第一个是 topology。The second step is what's your input data? What's your output ground truth? So the second step is data collection. What's your input data? What's your output ground truth or labeling? So you have a topology, you have a data, and then you start to use gradient descent to learn it, to optimize how do you want to learn it. So how do you learn? So 3 steps: topology, clear the data with ground truth, and then what's your loss from? Sorry, how do you optimize in order to get the parameters as the need? Okay, 3 steps. And then we already talked about each neuron, right? Each neuron is this function, Wx plus b of theta. So the same as we just talked about the equation, the linear equation, linear combination, Wx plus b. B is bias. But we need to have an activation function, F. It's the linear discrimination. So the same as the supportive vector ratio, the kernel function. So this activation function equal to kernel function of SVM. And this is your output. So this kernel function, also called activation function, exactly the same. So this is one neuron. 这一个圆这样子啊。So this is a sigmoid function for activation function. 上次讲过。好 So here I want to talk to you the activation function. This one. So this is value. So suppose we have two x1, x2, 2 dimension. This x1, x2. Suppose this one. That means this is E. And you are waiting to train the W. Right? So W is what? W, you control the rotation. You control rotation. And you plus linear combination together. And plus B. B is what? Bias. Is threshold. Is translation. So this is rotation. This is translation. 就我刚刚讲的。然后呢，你出来的结果 your result. So this is linear discrimination. And we want is the nonlinear is better. So we have an activation function, for example, sigmoid, become nonlinear output here. So here is not only nonlinear, it's also normalized between 0 and 1. Kernel function doesn't mean the output will be between 0 and 1 or -1 to 1. But here, for the neural network, we hope the output probability is between 0 and 1 or -1 and 1. So here we use this one with the sigmoid. 我们在做 SVM 的时候的 kernel function 输出不一定要介于0到1，所以它 kernel function 好多种。但是因为我们这里是 deep learning 是一个几率 neural network 是一个几率东西，我们希望输出是介于0到1或负1到1，所以我们只选择固定那几种这样子。所以我们要让输出介于0到1之间，就这样。那刚刚同学问的很好，问的很好是什么？我们整个 neural network 这个项目，这个 neural network。我先解释一下这32页这里就 suppose your input is 20 by 20 pixels, so input has 400 dimensions. 你输了400个影像，20就400个，对不对？那我刚刚讲的一个 neuron 就是一个 linear discrimination. 那 after activation function 变成 linear discrimination. 那为什么要这么多个？因为就刚问的很好，就是这我有400维，400维 is not easy. Just use one neuron to do separation. It's impossible. So probably neuron 1 is based on the input. Suppose input x1 to x10. Based on this 10 input, I do some discrimination. Neuron 2 is input 11 to 20. So 400, suppose there 400 here input, right? So here for each neuron, suppose 400 as separate to 10, 10, 10. So I have 40 neuron. 只有40个 neuron。那each neuron deal with only 10 dimension。所以我把400维每10维分一下，每10维经过一个转换式这样转过来。但他会自己认的，自己几维他会自己决定，他会自己决定。我是举例，所以这里就会变成400，就有些人就分，你看400维的可能就分这个 block， 先分这个 block， 分这个 block， 分一次分一个 block 呀。400维的空间，我每次先把这个 block 拿起来，稍微做一下分类，再分类，再分类，这样子，是这样子，这样的意思。没办法一次把它分完，没办法，你只能这样分区分。那所以为什么后面会有一种 close？ 为什么我要把这个 map close？ 因为你不能只这样区分，因为你可能有些眼睛跟鼻子关系什么关系，所以后面会当 sampling， 然后要去整个要去考虑到 local information， 所以当 convolution local information， 然后考虑 global information， 所以基本上观念是这样子，这样去区分，但是重点都是他把它做 discrimination 这样子去区分，就这样，物理意义就跟刚刚讲的一样，所以这是一个很复杂的东西，但是你不要把它想那么复杂，就刚刚讲那些观念，因为它是从machine learning观念过来的。好，那我们来继续讲什么 ？This is one example. So suppose 假设你想400维里面有前面有2维是这样子，有这2维，400维里面有其中2维是这样子，2维这样。但是2维你发现这2个红点了，你要做这个表格，你希望 input is this one, output is this one. So this is the exclusive of all problems. Output you want to do this one. So your input is this one. So input distribution, original space is this one. But your output is you suppose that this is this one. Red one is this one. Blue one is this one. So your output has 0 and 1. So how can you separate or discriminate red from green and from blue？ 你怎么把红色跟蓝色这2列把它分开？线性怎么切 ？If you use a linear discrimination， 你这怎么切都切不开。这4点你要分成2类，切不开。就是我不要这个 activation function 的话，我只用 linear 切不开。那怎么办 ？So if you do think about before, if you do the PCA and LDA, that's reduce the dimension and separation. But if you do SVM, they'll cut you to very high dimension and do linear discrimination. So didn't each time they just slightly use one small activation function, do a little bit discrimination. 就那个 deep learning 它每次只转换一点点，不要那么冲动转那么大点去这样子。所以它怎么做呢？做这样的这个，它就是你先不管这个，就是它去设计一个 activation function， 所以我们输入是这个，输出是这个。但是 after activation function become A1 and A2, and they hope that this one A1 and 2, so they hope red one will be here, and blue one will be here， 就是这2个 blue 上面，这2个 blue 它会把这个要把让这个 activation function 让这个跑过来这里，让这个跑过来，所以要设计一个 activation function。让蓝色跑过来，是非线性转换过来，那红色在这边。So your input is x1, x2 domain. This is your input. Your input is x1, x2 domain. Your output will be new domain A1, A2. This new domain A1, A2, and your result will be here. So after this one, that's meaning you can discriminate this four kind of combination， 就是你要找到一个 activation function 产生 A1 跟 A2， 这是非线性的哦。那 A1、A2 让你输出的到新的空间。Original dimension is domain is x1、x2，the new domain 是 A1、A2， 新的 domain 在这里输出嘛，就是那你这个新的 domain 就可以用一条线把这个区分出来。那这条线事实上就是我们的 W1 跟 W2 公式 ，rotation 跟 translation。所以这条线代表你有 W1， 有 W2， 有 B。所以这条线基本上，你看啊 ，Z1 是 X 轴嘛，这是 X1、X2， 你先转到第一个轴，这 A1 这个 Z1 的轴，它转到 A1 这个轴。那这里有 W1， 这个 W2。W11 W， 对不起 ，W11 W12， 那这个走的 W21 W22， 所以它每个这个这个就有一条线这样子，这两个区分，所以这条线是 W1 W2， 对不起 W11 W12 bias， 像这两个 bias 这样可以哈。所以重点不在这，重点是说你每次只转一点。区分这个 block 我把它区分开，这个 block 我把它区分开。OK， 基本上 activation 方式就会做这个事情。这个 ，so originally x1 x2， 再回到这里是 original x1 x2。Page 30. So after the first one, this A1. Is A2. The input is x1, x2. After activation function, it will become this value. For the A2, will become this value. And then you become the new domain A1, A2. So for this one, A1, A2 will become this result. 这个你可能要想一下，这个例子你要想一下，把你搞不清楚。就是输入是 x1、x2。输出是 A1 这里 ，A1 是，但是是它设计出来的，但是输入是A2 值，所以意思是什么？意思是说，假设你这个空间 input is many， 那你这很多 neuron， 那最后会设计出一个大的洞，在很大的维度里面有一个很大的那个 hyperplane。会把你这个区分出来，记得这是一个 neuron， 这是第二个 neuron。那你很多 neuron， 每一个记得，这每一个是这里的一个而已，一个而已。所以这个图啊，就是你的输入，这是一个 A1 一个维度，这一个维度。那这些维度的总和，新domain的总和，有一个 hyperplane 帮你分。但是记得，你第一层没办法完全分开，所以第一层是没有成功。所以你还要第一层分完，还在第二层、第三层、第四层，所以越 deep 就把你越区分的越干净，这样子，是这个原因。那我们后面为什么要加？后面新的为什么要加 loss function？ 就 loss function 上，因为你要想，我所有的参数都是从 loss function 里面被 propagation 推回来的，所以我的 loss function 如果有加一些 constraint 的话，什么叫 constraint？ 就是 margin。你有办法只加一些 margin， 加一些 between， 加一些 within 这些 constraint 的话，你输出来的结果就会把这个推得越开越好。所以我们刚刚讲的 LDA， 我们刚刚讲的 SVM 的 within、between、margin 这些东西是在 loss function 那边动手脚。经过这个 loss function 这 equation 动手脚，可以把这些都根据那 equation 动的手脚被 propagation 回来以后，它就会自己调， 参数会自己调到一个最好的 domain，让你一关关分出来。所以我老师跟你讲说，loss function 现在越来越多 constraint 进来。那我那个下礼拜我在教 SVM 的时候，SVM 就是打 branch 加一些，打 branch 是一个 loss function， 它把它加一些 constraint， 让它 margin 变大。那我们现在 deep learning 也是慢慢的把最笨的从那个mean square difference and cross entropy 没有 constraint， 现在慢慢加 constraint 进来。所以那个 face recognition 那些 paper 都是加很多 marginal 的观念进来的，这样子，属于 loss function。所以 loss function 本身，你在 network 里拿的最简单的 network， 那些 network 都不难哦 ，face recognition network 都很单纯，它重点在 loss function 那边，这样子。Okay, so that's it for today's lecture. Again, next week we don't have a class. You want to see me? I'm in Taipei 那边。OK， 好，那就先这样子，谢谢。你们有问题可以问我。